Hello everyone, a very good evening. Welcome to this video on the last day of 2021. I am Nitin Verma, a chemistry faculty at Infinity Learn by Sri Chaitanya, and here I am back with our amazing series on Bohr's model of a hydrogen atom. If you have not watched any of our videos before, then please do subscribe to our YouTube channel Infinity Learn, where we come up almost every day with amazing content, with amazing videos, with concept and PYQs, right? So do subscribe to our channel and press the bell icon so that you get the notification and you take out time from your schedule to attend our sessions, right? So I've already taken 2 sessions on Bohr's model because this is a very important topic from the structure of atom chapter, and this topic is common to both physics and chemistry, right? So it is really a very important topic. There are many postulates in Bohr's model which we basically study in this topic, and in the previous 2 sessions I have discussed some of them at length in detail, and today we will be winding up with this topic, okay? So actually for today I have taken some questions, some PYQ, some interesting questions which will clear your concept as well as give you some practice as related to this topic, okay? So without much delay, let's get started. Before we start, there's a small announcement for you. We are running courses, regular courses, as well as there are doubt subscriptions in case you are studying, and whenever you have any doubt, you can always go to that doubts app and have your doubts cleared, right, instantly, okay? And then there are many services which we are right now offering on Infinity Learn platform. If you use my coupon code Nitin40, then you will get 40% discount across all subscriptions, all courses, all services, right? So do not delay, make your preparation better with us. Let us work together and bring you closer to your aim. Alright, so talking of bringing you closer to your aim, I have some questions for you here. First question is, given below are 2 statements. Statement 1, Bohr's theory accounts for the stability and line spectrum of Li plus ion. Okay, and the second statement is Bohr's theory was unable to explain the splitting of spectral lines in presence of magnetic field. Okay, in this question you have to assess which of these statement is correct, right? If both statements are correct, or one is correct, or neither correct. Okay, so let us see the first statement. Bohr's theory accounts for the stability and line spectrum of Li plus ion. Is there anything wrong in this statement? Yes, there is. We know that Bohr's atomic model is actually applicable to 1 electron species, right? This model is actually applicable to 1 electron species. The atomic number of lithium is 3, and plus 1 means you have removed only 1 electron. So technically lithium cation contains 2 electrons, and hence we cannot apply Bohr's model to this species, right? So basically it does not account. So this statement is incorrect. Okay guys, right? Now let us go to the second statement. It says that Bohr's theory was unable to explain the splitting of spectral line in presence of magnetic field. Yes, this is correct. Can you guys tell me what do we call this phenomena? The splitting of spectral lines in presence of magnetic field. This was something that scientists had earlier observed, and they were expected to be explained by Bohr's theory, but unfortunately they could not, right? This we call Zeeman effect. Okay, and when we talk of Zeeman effect, we should also mention Stark effect, because Stark effect is the splitting of spectral lines in presence of external electric field. Okay, so in fact these are some of the limitations which you guys should remember, and I will take this opportunity to just recapitulate all the limitations of Bohr's theory. First limitation is that it is not applicable to multi-electron systems, as in the case of Li plus ion, right? So whenever you have 2 electrons or more, we cannot apply. So it is not applicable to multi-electron systems, first. Second, it does not explain the nature of bonding, right? It is a very essence of chemistry, how do atoms combine, form bonds, and form bigger, larger, complex molecules and structures. So Bohr's theory failed to explain that, okay? Then these were 2 of the prominent drawbacks, that Bohr's theory could not explain the splitting of spectral lines. in presence of magnetic field as well as electric field, right? The former is Zeeman effect and the latter is Stark effect. Then with the help of advanced instruments, we observed that the spectral lines which were initially singlets, that means one spectral line, with the help of high resolution instruments we observed those spectral lines still consisted of multiplets like doublets, triplets, quartet, pentet, like that, okay. So Bohr's theory again cannot explain that. So there are a lot of limitations of Bohr's theory, but it's okay, we learned something about the structure of atoms, so we accept it and move on to the quantum mechanical model, okay. So this statement 1 is incorrect, but this statement is correct. So the correct answer becomes B, right? Only statement 2 is correct, right? Okay, so let's move on to the second question. This was there in JEE 2021. You have to again find out the correct statement as per the Bohr's atomic theory from this list, okay. Now this is a good question because with the help of this question alone you can revise most of the points of Bohr's theory, okay. So let's first take this statement. Kinetic energy of electron is proportional to z squared by n squared, right? Now if you have watched my previous sessions, then I have discussed the energy postulate in detail. In fact, in the part 2 of this series, there I have discussed the total energy of electron, which we call En, is actually the negative of kinetic energy, right? It is actually the negative of kinetic energy. So, and it will be, what was the total energy? It was minus of Rydberg constant z squared by n squared, right? So our kinetic energy is negative, cancels out. So kinetic energy is Rydberg constant z squared by n squared. So yes, this postulate is correct. Ke is proportional to z squared by n squared. Second, the product of speed of electron v and principal quantum number n is proportional to z square. Let's verify that. Let's check that. Kinetic energy, guys, is equal to half mv square, right? So velocity will be proportional to under root of kinetic energy. Very simple, right? Now kinetic energy depends on this fraction, right? Kinetic energy is proportional to z square by n square. So velocity will be proportional to z square by n square. That is, velocity will be proportional to z by n, right? No need to mug up the formula. You can derive it here itself. Velocity is proportional to z by n. Clear, right? Now the product of speed of electron, speed velocity we can call it, right? We don't differentiate here. So velocity is proportional to z by n multiplied by principal quantum number, which is again n. So n cancels out, so what remains? Z. So no, this statement is incorrect. It is not proportional to z square, it is just proportional to z. Okay guys? Then let us come to the third statement. The frequency of revolution of electron in an orbit is proportional to z cube divided by n cube. Let us check. What is the formula frequency of revolution? Frequency of revolution, can I say it is velocity divided by circumference? Right? It is the velocity of electron divided by circumference. Okay? Velocity is proportional to z by n. We just saw it. Velocity is proportional to z by n. And circumference is 2 pi r. And in the first session of my this series, we had derived the expression for radius of stationary state. So please go back after this session and just revise that, okay? So radius is proportional to n square by z. Radius of nth stationary state is proportional to n square by z. So let us put it here. It is n square by z. So now you can find out the frequency of revolution is proportional to z square by n cube. So this part is incorrect, right? So this statement is also incorrect. You see, we are getting to revise a lot of things just with this question. Fourth, the Coulombic force of attraction on an electron is proportional to z cube by n4, okay? Now, what is the magnitude of Coulombic force? It is k z e square by r square, right? Is that clear? The Coulombic force is k, proportionality constant, z square by r square. Z is atomic number, radius, right? See, r is the distance between the nucleus and the electron, and this is what we call the radius of a stationary state. Now r is proportional to n square by z, so r square will be proportional to n square का square means 4 divided by z square. Is that clear, guys? ठीक है. So Coulombic force will be proportional to, so let us remove this, and because we are taking proportionality only, so this will be z divided by n4 by z square. So this will be z cube divided by n4. Is that clear? Right? So this will be z cube by n4. Yes, so this statement is correct. Okay, so the first statement is correct, second statement is correct. That means the correct answer to this question is option B. Is that clear, guys? I hope it's clear. Okay, let's move on to the next question. The ionization enthalpy of hydrogen atom is given to you in this question, and what is asked is the energy required to excite the electron in a hydrogen atom from n is equal to 1 to n is equal to 2. Simple question, okay? Now again, please go back to our second video, and there we have discussed that the ionization enthalpy of electron is nothing but the kinetic energy of electron in magnitude, right? In magnitude. Is that clear? Okay. So, and what is the kinetic energy equal to? It is equal to the negative of electronic energy. It is equal to negative of electronic energy. So can I say the negative ionization enthalpy is equal to negative, and electronic energy is Rydberg constant z square by n square, guys. Okay, right? So minus minus becomes positive, so it is RH z square by n square. The ionization enthalpy of hydrogen atom, so Z will be 1 and N will be 1, right? Because we assume that in a hydrogen atom the electron is present in the ground state. Is that clear? It is present in the ground state, so the value of N is 1, and for hydrogen atom atomic number is also 1. Is that clear? Right? So Z is 1, N is 1, it is equal to RH. Ionization enthalpy is nothing but equal to the Rydberg constant. So this is the purpose of the examiner. When they give you some values, you are supposed to use them, right? So this value is 1.312 multiplied by 10 to the power 6 joule per mole. So I explained you comprehensively what is the purpose of this value, okay? Now the question is, let us come to the question, the energy required to excite the electron in a hydrogen atom from n is equal to 1 to n is equal to 2. Is that clear? Now what is that formula? That formula is, I can skip z square because hydrogen for hydrogen z is 1, so it will be 1 upon n1 square minus 1 upon n2 square. It's very easy, just substitute the values over here in this formula. So it will be 1.312 multiplied by 10 to the power 6 joule per mole, and 1 upon n1 is 1, guys, okay, and n2 is 2, so it will be 1 minus 1 by 4, so it's 3 by 4 basically. So when you multiply 1.312 multiplied by 10 to the power 6, when you multiply it by 3 by 4, it will be what? It will be approximately, so it will be 0.984. Yes, so this, you will get this as the correct answer. Is that clear, guys? I hope you understood, right? Okay, so let's move on to the next question. Understood, guys? The wavelength of the radiation emitted when the electron in a hydrogen atom falls from infinity, means as n is equal to infinity, right? Falls from infinity to stationary state 1, means 1, would be, given the Rydberg constant is this. Alright, now again the energy, the wave number would be Rydberg constant, and electron is falling from infinity to stationary state 1. It's a simple transition, okay? we are talking about hydrogen atom, so Z is 1, forget that. We are talking about wavelength, and for what transition? From infinity to stationary state, okay, right? So it will be 1 upon 1 square minus 1 upon infinity square, so it will be 1 minus 0, that is 1, right? So wave number is this, right? It's simple, 1 upon n1 square minus 1 upon n2 square, and you know that wavelength and wave number, frequency, they are positive values, right? So only energy can be negative, which means that energy is released. So in this case, wave number is this, and we know that wavelength is a reciprocal of wave number. So our wavelength would be 1 upon clear, guys? Is that clear? Right? So it is 1 by 1.097, that is little less than 1. So I'll take care of it later. So it will be 10 to minus 7 meter. And you guys know 1 meter is 10 raised to power 9 nanometer, right? So it's approximately 100, okay? So this number multiplied by 100 nanometer, okay? So your answer is little less than 100 nanometer. So you don't even have to calculate. Yes, this has to be the answer, right? So this fraction is 1 upon some little bit larger than 1, right? So it will be little less than 1 multiplied by 100. So answer is 91 nanometer. Is that clear, guys? Next question. It's a previous year question. In Bohr series of lines of hydrogen spectrum, the third line from the red end corresponds to which one of the following interorbit jumps? So basically you read the question, we are talking about the third line from the red end. Third line from the red end. So if you look at electromagnetic spectrum, so this is the visible portion which our eyes are able to detect, right? Beyond this violet we have ultraviolet, and below this red we have infrared, right? Poor, infra, and ultra means superior. Is that clear? So red end and this is violet end. Is that clear? Now if you have read hydrogen atom spectrum, then you should know about all the series. Lyman series, Balmer series, Paskin series, Brackett series, Freund series, Humphrey series, right? And you should know the value of n final for every series. For instance, for Lyman series, electron drops in n is equal to 1 starting from any orbit, right? For Lyman series, electron can begin from any orbit higher than 1 and ultimately drops to 1. So likewise, for Balmer series, electron drops to second orbit. For Balmer series, electron drops to second orbit, okay? It can begin from anywhere. Now what you should also remember is the region of electromagnetic spectrum where the energy of the absorbed or emitted photon lies, right? So for instance, in Lyman series, electron drops to n is equal to 1 irrespective of where it's beginning from. The emitted energy will lie in the ultraviolet region, in this region, okay, right? For Balmer series, electron drops to n is equal to 2 beginning from anywhere. So the emitted energy will lie in this range, visible range. Now you guys know in this direction your energy is increasing, your frequency is increasing, right? Your wavelength is decreasing. So what we are talking about is electron drops to second orbit. At least it has to start from third. It has to start from third, okay? So the minimum energy will be emitted from 3 to 2, right? So I'm talking about red end, okay? From the red end, I will begin just from above. For the violet end, I will begin from infinity. I'll begin from infinity, okay? So from 3 to 2, minimum energy. From 4 to 2, a little bit larger amount of energy. From 5 to 2, little bit larger amount of energy, right? So the third line from the red end means minimum energy. Minimum energy is emitted when electron drops from 3 to 2. Is that clear, guys? So for third line, the corresponding transition is 5 to 2. I hope this part is clear, right? Clear? Okay, so let's move forward. What is the wave number for the shortest wavelength transition in the Balmer series? Again, we have a question from Balmer series and it is a previous year question. So Balmer series, electron drops to n is equal to 2. It can begin from anywhere, right? But there is a hint, it has to be the shortest wavelength transition, okay? Now if you guys remember the Planck's equation, then E is equal to hc by lambda, that is energy depends inversely on the wavelength. So if the wavelength is shortest, energy will be highest. Minimum wavelength, maximum energy, okay, right? Now we assume that for hydrogen atom ground state is 1 and mathematically there are infinite orbits. Mathematically there are infinite orbits, okay. So for maximum amount of energy, which transition should we consider? See, for the Balmer series, electron drops to 2, right? That is fixed. Electron has to drop to n is equal to 2, right? Now if it begins from n is equal to 3, guys, it will be minimum energy, okay, because it is starting just from the upper level, okay. So in order that the amount of released energy is maximum, because if released energy is maximum, wavelength will be minimum, electron should start from the topmost level, that is n is equal to infinity. So the corresponding transition for maximum energy or minimum or shortest wavelength, always remember the transition is from infinity to whichever series you're talking about, infinity to 2. Is that clear, guys? Okay. Now we can find out the wave number. Wave number would be 109,737 centimeter inverse multiplied by 1 upon, it is starting from infinity, right, and it is dropping to 2. So in order that it is positive, I will take it to be like this. So 1.2 square is 4, 1 upon infinity is 0, you have to divide it by 4 and you can see which answer will be correct. Yes, you thought it right, the correct answer will be 27. Is that clear, guys? Okay, so it was a previous question. So there are many formulas, many tricks, many concepts which we learned in today's class. Is that clear? So again, thank you for joining this session and Happy New Year to you all. Keep studying, keep enjoying, and if you want to make your preparation better, do join Infinity Learn. We have lots of amazing things for you to help in your preparation. Bye-bye.